In this video, I'm going to demonstrate how to do synthetic division to divide one polynomial by another polynomial, and I'm going to use some of the homework problems as examples from page 326. So this is number 5, and we're dividing x to the 4 plus blah 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 by x plus 4. So what we want to do is put negative 4 in the box. That's because when you look at this divisor right there, if it was x minus k, you would put k in the box. If it was x plus k, you would put negative k in the box. So if it was x minus 4, you would put 4 in the box. If it's x plus 4, you put negative 4 in the box. It's kind of just if it was set equal to 0 and you were to solve it, it's what you would get when you solved it. That's the number that goes in the box. So negative 4 is in the box, and then the coefficients of all of the terms in the numerator go in a row. So 1, x to the 4th, 4, x cubed, 2, x squared, 9x, and 4. And then you leave a space, draw an arrow, leave a row for space, draw a line, and then you drop down the first number. You multiply it by the number in the box, 1 times negative 4. You write it here, and then you add the column, 0. Do it again. Take 0, multiply it by the number in the box. That would be 0. Add the column, 2. Take 2, multiply it by the number in the box, negative 8, write it here. Add the column, 1. Take 1, multiply it by the number in the box, write it here, negative 4. Add the column, 0. That last number is the remainder. When the remainder is 0, it tells you that the polynomial went in evenly. And the rest of this set of numbers represents the remaining polynomial for your answer. So remainder is this number. The next one over is the constant. The next one over is the x to the first. This one is the x to the second, and this one is the x to the third. So that would be 1x to the third plus 0x squared plus 2x plus 1. And that's the answer to the problem. When you divide, that's what you have left. Now there's one other piece of information we get out of this. Because it went in evenly and our remainder was 0, we know that our original quartic expression, which was x to the 4th plus 4x cubed plus 2x squared plus 9x plus 4, actually factors into x cubed plus 2x plus 1 times x plus 4. So that's kind of handy if you had to factor something. Synthetic division, if you get a remainder of 0, tells you what a factor is. Okay, let's move on and look at number 11 from the homework, page 326. Same idea. Because we're dividing by x minus 1/3, I'm going to put 1/3 in the box. It doesn't have to be an integer. You can use a fraction. And then the coefficients on the numerator go in a row. So we have 1/3 for x cubed, negative 2/9 x squared, 1 over 27 x, and then 1. Bring down the first number, leave your space, bring down the 1/3, multiply it by the number in the box. 1/3 times 1/3 is 1/9, write it here. Add, we have negative 1/9. Take that, multiply it by the number in the box. That will give you negative 1/27. Add the column, 0. Multiply by the number in the box, write it here. Oops. 0 times 1/3 is 0. And add, and we get a 1. 1 is the remainder. It did not go in evenly. We have a remainder. And the rest of this here would represent, let's see, if 1 is the remainder, then 0 is the constant, negative 1/9 is for x to the first, and 1/3 is for x squared. So we have 1/3 x squared minus 1/9 x, and then plus, when you have a remainder, put it over what you divided by, so 1 over x minus 1/3. And that is the answer to the problem. Moving on to number 13. Dividing by x minus 2, so we put 2 in the box. And then we have 1x to the 4th, negative 3x cubed, negative 4x squared, 12x, but there's no constant. It's as if there was a plus 0 on there. So we need a 0 to hold that place. Bring down the first number, multiply it by the number in the box, write it here, and add. Multiply by the number in the box, write it here, and add. Multiply it by the number in the box, write it here, and add. Multiply it by the number in the box, write it here, and add. And that last number is our remainder. So then the rest of it, this 0 here is the constant, and then this is for our x term, this is for our x squared term, and this is for our x cubed term. So we have 1x cubed minus 1x squared minus 6. And that's our answer. And the other thing we know from that, because we had a remainder of 0 and x minus 2 went in evenly, we know that the numerator, which was x to the 4th minus 3x cubed minus 4x squared plus 12x, can be factored into, I made a mistake. So if we go back, this was the x term. There's an x on there. Okay. As I was saying, that original problem can be factored into x cubed minus x squared minus 6x times x minus 2. Okay, and 15. So we're dividing by x minus 1, so we put a 1 in the box. And then we have 1x cubed, but we don't have an x squared term, so 0x squared. And then we don't have an x term, so 0x. And then we have our constant negative 1. So it's as if we had x cubed plus 0x squared plus 0x minus 1. And the zeros are the placeholders. Bring down the first number, multiply it by the number in the box, write it here, and add. Multiply by the number in the box, write it here, and add. Multiply by the number in the box, write it here, and add. Zeros are a remainder. So x minus 1 is a factor. It went in evenly. And the numbers we have left represent the answer. So this is the constant. This would be the x to the first, and this would be the x to the second. So we have 1x to the second plus 1x plus 1. And because we got a remainder of 0, we have factors. So the original numerator, x cubed minus 1, can be factored into x minus 1 times x squared plus x plus 1. Now, if you stop and think about that, that should not be a surprise because this is a difference of cubes. Remember the difference of cubes factoring formula? We have it right here. And there's your same sign, opposite sign, always positive. Everything is just like the difference of cubes formula. So that is awesome.